Saxon's Trig, lesson 113, is about synthetic division, and then it talks about zeros and roots. So synthetic division is a way in which we can avoid having to do long division with something like x plus 3. You know what, I'm going to change this so that it kind of mirrors the first example, x minus 3, and then something like, and I'm going to put these in order, x cubed minus 4x squared plus 13. So when we did a long division like this before, we had to compare x compared to x cubed, which meant that we had x squared missing, and then multiply. X squared times x is x cubed. X squared times negative 3 is negative 3x squared. Subtract all of that, cancel this part, negative 4 plus 3, negative 1 x squared, drop. And now we wouldn't want to drop the 13, we'd have to drop a 0x term, which I should have written up here, but since this was just for an example, I didn't really care. And then repeat that whole process. Compare x to negative x squared. That needs another negative x. Negative x times x is negative x squared. Negative x times negative 3 is positive 3x. Subtract the whole thing. This cancels off. 0 minus a 3, negative 3x. Then I can drop the 13, repeat the process one more time, and get the answer. Okay, so instead of having to do all of that, synthetic division says, let's do the same problem. Now, when they gave it to me in example 1, they gave it as negative 4x squared plus 13 plus x cubed, and they said divide that by, lost the problem for a second, negative 3 plus x. So when this is what I'm given and I'm going to do synthetic division, I'm going to pull the coefficients off of this part, but I most definitely want them in descending order with a number for every single exponent. So x cubed is the highest, so 1 is its coefficient. Do I have an x squared? Yes, its coefficient is negative 4. Do I have an x term? No, that's where I said I needed to add a 0. So we add a 0 here. So x cubed, x squared, x. Do I have a non-x term? Yes, the 13. And then for synthetic division, instead of doing my division box, I'm doing an upside down division box backwards. And then I'm going to put in here the number part that I'm testing. Now, when it's given to me with it attached to the x, I need to change the sign. So in order, that would actually read x minus 3, which is why I've changed it over here. However, when I'm doing synthetic division, I'm not using the x parts. So what I'm actually testing is change the sign when you're pulling it away from the x. It's like pulling it out of a parenthesis. So when you go in or out of the parenthesis, you change the sign, same concept. So since I'm unattaching it from the x, I'm going to use positive 3. Okay, so here's how synthetic division works. The very first coefficient always drops down into my answer, and then I do the multiply. 3 times 1 is 3, and always add negative 1. Negative 1 times 3, negative 3. Add negative 3. Do you see that I'm getting here the same things that I got up here doing it the long way, but I'm doing it without all the x's, which can cause confusion? That's why synthetic division works. All right, so back to where I was. 3 times negative 3 is negative 9. Add that together, gives me a remainder part of 4. Now, I didn't finish my long division quite that far. Now let's put this back into its answer format. So I know that the first coefficient is a 1. My highest exponent value before was x squared. Notice that in the answer it's always 1 less than that to start. So that's what you want to do here. 1x squared. So take 1 off the remainder of the highest one to start. Then minus 1 and go in descending order. X minus 3 with no x, and you heard me automatically say that this last number is my remainder. So if I had finished this, if you remember, you take your remainder and you put it in a fraction with this as the denominator. So that's what you're going to do here. 4 is the numerator, and then this goes back to its original with its x minus 3. Wait a minute. Yes, 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 x minus 3 format. And this is the answer, doing a very short, taking up far less paper solution to get to the answer. So let's do example 2. Divide, and did they put this in order for, they did, okay. So I'm gonna just pull the coefficients as, well, no, you'll wanna see it. 2x to the 4th plus x squared plus 2x minus 1, and it's being divided by x plus 3. So in our, I'll just go ahead and do this and attach that as a negative 3. So x4 is the biggest, 2. Do I have an x cubed? Nope. Do I have an x squared? Yes, implied 1. Do I have a plain x? Yes, 2. And then our non-x, negative 1. Drop our first number is 2. Negative 3 times 2 is negative 6. Add together. Negative 6 times negative 3 is 18. Add together. Negative 27, 57, 55. Okay, yep. And then negative 55, a positive 15, 165. So 164 is my remainder. Okay, so let's put our answer. I think I have room to do it. So 2 is our first coefficient. X4 was our highest amount, so we're going to do x cubed, then minus 6x squared, then positive 19x, then negative 55 with no x, and a remainder of, oh, I don't quite have room, 164 over top of the x plus 3 that we had originated with. Make sure I have no errors, minus 6, positive 9, yep, and there is your answer there. Now, part B switches gears to zeros and roots. And in this terminology, they take a moment to say that zeros and roots are basically the same thing. They mean answers. So when I use the word 0, I'm talking about the answer to a polynomial. Things like these without the equal, they're polynomials. And the root is used as the answer for an equation, so something equaling something else. So now that they have clarified those things, so that when you see the word 0 or the word root, your brain should just say solve for an answer. So example 3 calls for use synthetic division to see if negative 2 is a 0, an answer for this given equation. So in the upside down division box, I'm testing negative 2. Now when I read that, I did not say x minus 2, so it's not attached with an x. I'm not changing the sign. I'm testing exactly what it says. And then the equation they give is x to the 4th minus 2x cubed plus 5x minus 10. So when I pull my numbers, x to the 4 is the highest, so it starts with the 1. Do I have an x cubed? Negative 2. Do I have an x squared? Nope. Do I have an x? 5. Non-x, negative 10. All right, drop our 1. Negative 2 times 1 is negative 2, adds to negative 4. Negative 2 times negative 4 is 8. 0 plus 8 is 8. 8 times negative 2 is negative 16. Add together negative 11. Negative times negative is positive. That makes 22. And then minus 10 leaves a remainder of 12. Now, if this number comes out anything other than 0, this is not a root answer or 0 answer. So there's your other clue. It's a 0 answer if it comes out 0 at the end. If you have any other remainder, it's not. So basically your answer here is negative 2 is not a 0. Now let's do example 4. Use synthetic division to see if negative 3, so exactly as it is, not attached to an x, and then the equation that they gave was 2x to the 4 minus 32x equals 0. And is it a root of that polynomial? So we're going to put in descending order. X to the 4th is the highest, 2 is the coefficient. Do I have an x cubed? No. Do I have an x squared? No. Do I have a plain x, negative 32? Do I have a non-x? No. And now we do our synthetic division. Drop our 2. 2 times negative 3 is negative 6, adds to negative 6. Negative times negative is positive 18, adds with 0, no change. 18 times negative 3 is negative 54. yes, and then adding those together, negative 86, and then multiply with another negative makes it positive 258. Okay, add together, get 258. So again, it is not 0. Oh, I hate it when they say it this way. Okay. It is not a 0 root, but they're saying because I was originally given it set equal to 0, there should be a solution that works, but negative 3 is not one of them. And that was the crazy way they worded that. The remainder is not 0, but 258, so negative 3 is not a root of the polynomial equation. Yeah, like I said, it was just wordy.